Hi, this is Lisa. It's time to review all of our factoring techniques. When you factor a polynomial, the first thing you want to do is look for any greatest common factors that the polynomial has. Then count the terms. If there are 4 terms, factor by grouping. If there are 3 terms, factor the trinomial. And there are a couple of techniques for doing that. If the leading coefficient is not 1, if the leading coefficient is 1, and if we have a perfect square trinomial. And then if there are 2 terms, check to see if you have a difference of 2 squares, and if so, factor that. Remember, a sum of 2 squares will not factor. If none of these techniques works, then the polynomial is prime. So we're going to start off with this first polynomial here. It has, we want to look at step 1, says factor out the greatest common factor first. When I look at this, I recognize that there is a common factor. My greatest common factor is 3. 6 is 2 times 3. 12 is 3 times 4. 15 is 3 times 5. And 30 is 3 times 10. So if I factor out my common factor of 3, I'm left with 2m squared minus 4m plus 5m minus 10. Now I have 4 terms. I'm going to try to see if I can factor those remaining 4 terms using our grouping technique. So I'm going to group the first 2 terms together and group the last 2 terms together. Look for a greatest common factor for each group. And I still have this factor of 3 out here, so we're going to keep that as we go down. 2m squared minus 4m, I have a common factor of 2m. This is 2m times m minus 2 times 2m. If I take out the 2m, I'm left with m minus 2 plus my second group. This is 5 times m minus 10, which is 5 times 2. If I take out the common factor of 5, I have left m minus 2. Keep that 3 out in front. Now when I factor out my common factor here, I have m minus 2. And in parentheses, what's left is 2m plus 5. And now my polynomial is completely factored. Have a few more examples to do. Example number 2. No common factors, but I notice I have 3 terms, so I have a trinomial. Leading coefficient is 1. So this is the easy one to factor. We know the first term, c squared, factors as c times c. And then we look at the last term. Negative 21 could be 1 times negative 21, negative 1 times positive 21. 3 times negative 7, or negative 3 times positive 7. And this is my winning combination. If I add negative 3 and 7, I get a positive 4. So c minus 3, c plus 7, and my trinomial is factored. When I look at example number 3, no common factor. When I look at 4 and 49, I know there's nothing in common there. But I do notice that the first term can be written as a perfect square, and the last term can be written as a perfect square, and it is positive. So I might have a perfect square trinomial. Remember, you do the first term, the last term, first term, last term, and you look at the middle term to determine what the possible sign here could be. And then you multiply the outside and the inside to check. 7 times 2p gives me 14p. 2p times 7 gives me plus 14p. 28p. That is my correct middle term, so that checks. So my perfect square trinomial factors as 2p plus 7 quantity squared. There's my square binomial. And this is our last example here, number 4. Again, I'm looking for, first I always look for that greatest common factor. When I look at this, 18 and 32 have a common factor of 2. I'm going to factor out the 2, and what I have left, 9a squared minus 16b squared. Now I have two terms. Is it a difference of 2 squares? Well, 9a squared is 3a quantity squared. I do have a minus, and 16b squared can be written as 4b quantity squared. I still have my factor of 2 out in front. I do have a difference of 2 squares. So I'm going to keep my 2 out in front, and my difference of 2 squares, remember we said we do parentheses, one with a plus, one with a minus. The first thing I'm squaring is 3a. That goes in the first spot in each parentheses. The last is 4b. That goes in the last spot in each parentheses. So my polynomial completely factored 2 times 3a plus 4b times 3a minus 4b. Completely factored. Now that we know all of our factoring techniques, we're going to talk about how to solve an equation by factoring. When you have exponents in your equations, you want to try and factor. We're going to use the zero factor property, which says if the product of two factors is 0, then one of the factors must be 0. So if a times b equals 0, then a is 0 or b is 0. We're going to use that in our solving technique. Solving equations by factoring. Step 1, get 0 on one side of the equal sign and everything else on the other side. Step 2, factor completely. Step 3, set each factor equal to 0 and solve for the variable. And step 4, check your work. So in example number 1, notice I don't have it that it's equal to 0, so the first step I have to subtract 21 from both sides. M squared minus 4m minus 21 equals 0. Get 0 on one side, everything else on the other side. Step 2 is to factor. Now this is a trinomial again, leading coefficient of 1, so I know it factors. M squared factors as m times m. Negative 21, 1 times negative 21, negative 1 times 21, 3 times negative 7, or negative 3 times positive 7. I wanted a minus 4 in the middle, so there's my correct pair, positive 3 minus 7. So in factored form, my equation becomes m plus 3 times m minus 7 equals 0. Step 3 says to set each factor equal to 0. So m plus 3 equals 0, m minus 7 equals 0. And solve for the variable. And this one, if I subtract 3 from each side, I get m equals negative 3. Add 7 to each side, and I get m equals 7. And then check your work. We want to check in the original equation to make sure that these are both solutions. So m squared minus 4m equals 21. That was my original equation. I'm going to write it down twice because I have to check m equals negative 3 and m equals 7. So if I substitute negative 3 in, negative 3 squared minus 4 times negative 3. Negative 3 squared is 9. Negative 4 times negative 3 is positive 12. 9 plus 12, 21. Yes, that is equal to 21. Next, I'm going to substitute 7 in. 7 squared minus 4 times 7. 7 squared is 49. Negative 4 times 7 is negative 28. 49 minus 28 is 21. That is equal to 21. It checks. So my final answer to this problem, negative 3, 7, those are the solutions to my equation. Let's do another couple of examples. 2w squared minus 4w. I do already have 0 on this side of the equation, so I can start by factoring. Common factor here, 2 times w minus 4 is 2 times w, so I can take out a 2w, and what I'm left with is w minus 2 equals 0. Set each factor equal to 0. 2w equals 0, w minus 2 equals 0, and solve. If I divide by 2, I get w equals 0. And in the other equation, if I add 2 to each side, I get w equals 2. So my solutions are 0 and 2. In example number 3, I have just 2 terms. Looks like I have a difference of 2 squares. 5p squared minus 8 squared equals 0. And I do have 0 on that side of the equation. Difference of 2 squares factors as a sum and a difference. First term 5p, last term 8. Set each factor equal to 0. 5p plus 8 equals 0. 5p minus 8 equals 0. And solve each of those equations. So subtract 8 from each side. 5p equals negative 8. And to get p by itself, I divide by 5. So p equals negative 8 fifths. Second equation, add 8 to each side. 5p equals 8. Divide both sides by 5, and we get p equals 8 fifths. So my solutions are negative 8 fifths and positive 8 fifths. And we have one more example. On this example, we don't have 4 on this side, but we also have a set of parentheses. Sorry, we do have 4 on this side, not 0, and we have parentheses. So I'm going to start by distributing to get rid of my parentheses. 3b squared plus 8b equals negative 4. And then I'm going to add 4 to both sides. I need 0 on that side of the equation. So 3b squared plus 8b plus 4 equals 0. Now I can factor. This is a trinomial with leading coefficient not equal to 1, so we always start by multiplying a and c. A times c is 12. Factors of 12 that add up to 8, right? That's what we're looking for. We want them to add up to that middle coefficient. 1 times 12, 2 times 6, that's my combination. So I split my middle term. 3b squared plus 2b plus 6b plus 4 equals 0. I'm going to factor by grouping now. So first 2 terms go together, last 2 terms go together. 3b squared times 2b, the only thing they have in common is 1 factor of b, so I'm going to take that out, and I'm left with 3b plus 2. Plus, in my second group, 6 is 2 times 3, and I have a factor of b, plus 4 is 2 times 2. They have a common factor of 2. Factor out the 2, and what we have left is 3b plus 2, still equal to 0. And now I have my common factors. 3b plus 2, and what's left is b plus 2 equals 0. Set each factor equal to 0 and solve. First equation, I have to subtract 2 from each side. 3b equals negative 2, and divide by 3 to get the b by itself. b equals negative 2/3. Second equation, subtract 2 from each side, and I get b equals negative 2. So my solutions are negative 2 and negative 2/3. And that concludes the video on solving equations by factoring.